Right, hello and welcome back to another series of videos, this time looking at UVs and how we can manipulate those in our material editor to do all sorts of effects and things. So I'm here in level 5, U5 UVs, and we're going to start having a look at what exactly UVs are and how they work. So if you've done some 3D modeling, you will have come across UVs as a way of assigning textures to an object. So if I have a look at this chair, this has UVs. We can turn them on here, have a look. And basically what's happening is every vertex has an assigned space in 2D in the UV space. And that works as a kind of lookup table. So it looks at the pixel, let's say up here at this top corner, looks at the pixel here, gets a mathematical grid reference, and then uses that to look up in the texture what's happening there. And so it's kind of like a way of mapping a 2D space to 3D space, but it uses this kind of mathematically defined grid of values to do that. And if we just quickly jump over to Maya and have a look, if I create a quick plane and then look at the UVs for this, bring up the UV editor. If you actually notice, the UV editor here has numbers. Now the numbering system's different in Maya and Unreal, and so in Unreal 0, 0 is up at the top left here, and in Maya it's down here in the bottom left, but that doesn't really matter. But the important thing is we've got numbers here that go from 0 to 1, and again in the other direction. So you could think if we were loading in, well, this is a 10 by 10, if I make this a power of 2 number, so let's say just a 16 by 16 grid, you could imagine this being a 16 by 16 texture, and each one of these faces is going to have a pixel that maps to it. Now obviously 16 by 16 texture is not very big, but if we plug in a 256 plane or even 1024, whatever, you can see it gets very dense very quickly. But what's happening is effectively that. So under the hood, the UVs are calculated mathematically from 0 to 1, and we get a kind of unique identifier for every pixel based on that grid reference. And we can use that. So if I jump back over to Unreal, if we open up this first example here, gradients, here we have that first example. So here we have a UV coordinate node. It's called text chord, or U-click is the keyboard shortcut to create this. Text chord 0, and it has this this appearance, this color, and it's Unreal rendering maths as color for us. And so there is a gradient in red, so 0 to 1 across, and a gradient in green, 0 to 1 down. And anytime you see these kind of red, yellowy, greeny colors, you can usually work out that it's something to do with UVs because it's that 2-channel data. We plug that into our texture and we get our texture sample. If we don't plug that in, it assumes the default. So it always assumes this text chord has a UV in there. Defaults to constant coordinate if not specified. Well, that's this node here. Constant coordinate. No, it's not. It's called texture coordinate. So terminology, a little bit lacking. Texture coordinate is this node, and it says here constant coordinate. Well, that's this one. So if we don't plug anything in, it assumes it's plugged in, and this allows us to look up in our texture where our model is. As I say here, you can think of it as a texture of 2D grid. So if I plug in just a 2D number, here, a float 2, 0.7, 0.7. Well, if I go to my texture, I'm zooming as far as I can, 0.7 across and 0.7 down, it's going to be this number here, 47, this kind of yellowy color. And that's what we're getting there. So if I were to pick, for example, 20, that's going to be 0.4, 0.3. Turn on live updates, and what we should get is a color that matches that 20 there. So we're able to use individual values to pick a pixel. Not very useful if you only want a single pixel, but that hopefully shows, shows what's happening here. These values are finding a grid reference in our texture. And any texture is just a grid. It's just a series of pixel color data in a two-dimensional grid, and we can access those individually. Obviously that's not very useful for applying textures, so what UVs are, rather than being single numbers, is a series of, or two different gradients. And if we have a look here, our UV coordinates, I've used the breakout float 2 just to separate red and green. Well, I'm separating U and V, obviously the terminology here is red and green, and we can see we get these two gradients. So we get black to white in the red channel, black to white in the green channel, and what that means is every single square has a unique identifier. So top left pixel 0, 0, bottom right pixel 1, 1, and so on. So middle will be 0.5, 0.5. And the other smart thing about these is these are mathematically defined gradients. It's defined in the code, in the way this works, that this is 0 and this is 1, and then it doesn't matter how big your texture that you plug in, it always has enough data, enough interest between those to calculate these exactly. And so here we've got a quick comparison. This is our text chord node. You can see text chord, this is our mathematically defined gradient. And if I just preview this texture here, if I plug that in, we get a super crisp, super sharp image, which is what we want. If we zoom in too far, we'll get texture. But you can see here, all the lines are straight, it's all very clear and clean. If I use this, which is I've called it a fake UV, this is the gradients, the same gradients, black to white in the same sort of order, but made in Photoshop. And if I plug that in as my UVs, you can see how much compression is breaking this, and you can see the quality loss. So it's worth remembering that these are mathematical gradients, and because of that, if you ever need to use a gradient in your texture, or in your materials I should say, you can use the gradients that come with the engine. Saves you having to use a texture lookup, saves you having to have any compression. And if we type in linear gradient, you might have seen this node being used a few times. That's all this is the same here. So if I open this up, it's the UVs masked at red or green, and that gives us a really nice way of working with gradients that are very accurate. Another thing to note, here my imported texture, we have this option, sRGB. So sRGB is what's known as gamma, or linear space versus gamma space. Basically, if I plug in this texture here, so this one has sRGB turned on, and if I plug that in to my UVs here, we're going to get some really bad distortion. So what's happening? Well, when computers were first invented and monitors were first being designed, versus gamma, the people making them, there we are, started putting in numbers and seeing what colors they got. And basically, the human eye is very good at seeing brighter colors and very poor at seeing darker colors. And so because of that, when you define colors purely by math, it doesn't make sense to have 0.5 gray, or it doesn't appear that 0.5 gray is halfway between black and white, because our color perception, or our brightness perception, is better at the higher ranges. And so because of that, what they did is they added this fudge factor, this kind of multiplier called gamma. And what it does is it changes the appearance of grays so that mid-gray, 0.5, looks like mid-gray, and effectively crushing the black values, having less data in the blacks and more data in the whites. And that's what this gamma curve does. That makes sense. It is useful if we're dealing with color as color. And what do I mean by that? Well, if I go to some textures, and if I just have a look in here for textures, this is a color map. It is rendered as colors. We want to see colors. We've authored it with colors, so we want to have sRGB enabled because we want the output to have that adjustment to it, so that the mid-gray is now visible as mid-gray. And so anything that you see rendered to the screen as color data, you want to have sRGB enabled. But if I go to something like noise or, well, my fake UVs, here with the UVs, I didn't want to render this. I want this to be a gradient from black to white. And so I don't want that compression to happen, that adjustment in the grayscale values. And that's why we're getting so much more of the texture. So you can see the texture's kind of been pushed sort of downwards and compressed down because the darker values have been compressed and spread out more, and the lighter values have been uncompressed. So anytime you're using masks or channels packed together, and if we open up another texture, if I do the starter content ones, so anything like here, so this should have sRGB disabled. It does not. Good old starter content, because this isn't designed to be color. This is designed to be ambient occlusion. Nope, ambient occlusion, roughness, and so this should have sRGB turned off. But let's pick an example that is correct rather than one of Epic's starter content. Are they all wrong? They all look wrong. Maybe they've been unpacked in the material. There's one that's, has this got it disabled? No, they really haven't made an effort with the starter content to disable sRGB. Any of these? This one. So this one does have it disabled. But yeah, basically anywhere where you're using your textures as not as textures, but as masks. So as when we're doing channel packing with masks together. Let's have a look at the Megascans ones. The Megascans hopefully are packed correctly. So here we have some Megascan assets, and there we are. So sRGB is disabled for this because we've got different values for our different channels. And this is named DPRF, so that's depth, I believe, or height, effectively. R for roughness, and F, which looks like fuzziness. If you are debugging things, you can always open up the reference viewer and see where things have been used, and then just open that. Let's have a look at this material and scroll down. So the fuzz material. So this has been edited a little, but the DRF texture, so I'm not actually using the red channel, and then roughness and fuzziness. But anywhere we're using our texture as individual channels rather than as color, we want to have sRGB turned off because of this reason. But if we're using just gradients, we can do this using UV gradients. Okay, a few other gradients we have available to us. So linear gradient we just mentioned, diamond gradient. If I have a look at this, it's going to be a nice square diamond. Again, just derived from UVs, and then radiant gradient exponential. Again, this is just a mathematically defined gradient from UVs. You can use these in place of textures if you build your material up in such a way, a bit like you would in Substance, of just kind of like starting with gradients. But most materials, or most things, are worth a little bit of texture. There's definitely certain advantage to doing things like little sparks and embers using a pure math circle, but actually when you look at them, they never have that pure shape. You always want to be a little bit of texture. And if it's something small where you think, oh, I don't need a texture, well, actually you can just get away with a small texture. So they are useful. You do want to use these, so masking out edges might be worth, but I don't think it's worth, or it's not usually worth, just relying on your gradients to build up your entire material, because you lose some of that quality that you can get from texture information. So good to use, good to know that they're there, but don't rely on them to do everything for you. Otherwise you end up things looking a bit artificial and a bit mathematically defined. So okay, so UVs, yeah, just a grid of data, just numbers from 0 to 1. We can use them to look up textures, get individual values, or we can use them as gradients. And then just a quick aside on sRGB, making sure that it is disabled for things that it should be disabled. Maybe not using the Epic starter content where it probably should be disabled, but isn't. Okay. Next time we'll have a look at tiling and how we can manipulate our UVs to create repetition in things.